Thanks, Moti. Hi, everyone. I'm Omri. I'm a data scientist at Microsoft, and I also lead the Presidio project, which I'll describe in a moment. But first, let's start with a story about how the NSA identified Satoshi Nakamoto. Anyone here doesn't know who Satoshi Nakamoto is? Okay, he's the guy who invented Bitcoin. He's also one of the world's most rich people. And he's anonymous. Nobody knows who he is. So how did the NSA identify him? They used stylometry. Stylometry is the way of comparing writing styles of different authors. And they compared his writing style, because he published blog posts and things like that, with trillions of other writing samples. More technically, they use term frequency as features, principal components analysis to reduce dimensionality and come up with a distance metric between Satoshi's writings and others. They are the NSA. They have access to literally every piece of data, like Google's, Facebook's, and Amazon's data centers. So coming up with candidates wasn't really a problem. They ran this process for a month, compared his writings to 1 billion people, and collected one positive match. Now, I have two things I'd like to talk about regarding this story. First, I have no idea if it's correct or not. Maybe it's fake news. You know, the NSA don't really write blog posts about the methods they use. You can ask Edward Snowden about this. And the second thing is that even after running this gigantic process by one of the world's most powerful organizations, how do you know that you actually got the guy? So maybe they got somebody else. Maybe Satoshi Nakamoto is actually a group of people. So Satoshi Nakamoto didn't reveal any identifying attribute about himself, but in many data sets, and I assume that maybe the data sets that you have in your organization, you do have these identifiers like maybe names or locations or IP addresses or credit cards, emails. So let's think together what you can do in order to Nakamotize or anonymize your data. So we'll talk about Presidio, which is an open source package to do this, which is completely free and you can just try it. We'll talk about some scenarios we have identified in which such tool is necessary. Then we'll go a little more technical about how to use NLP to do data de-identification, and finally how you can use it yourself if you're interested. So what is Presidio? Presidio is a production ready, so it's not just a Python package, it's a full service that you could deploy locally on premises, in any cloud, anywhere you'd like. Context aware and customizable data protection and PII anonymization service, mainly for text, also for images. PII stands for personal identifiable information, essentially all the private data of users or people that you have. It has two main components. One is identification. That's the part that we go through text and we look for different entities, PII entities. And the second phase of anonymization, in which we take everything we found in the identification phase and do something about it. We could either encrypt it, redact, hash it, or anything we'd like. Off the shelf, it already supports things like detecting credit card numbers, names, locations, financial data, but it's very easy to extend it to your own PII entity or to support something we don't currently support. And as I said, it's completely open source, completely free. It doesn't rely on anything commercial, and you could just go to this repo and check it out. So what are the scenarios in which you might need such tool? So a lot of us are data scientists, and we're working in a product team, but we don't have access to the production data. Because the production data has users' data and it has PII data, we're not allowed to touch it because we're not allowed to be exposed to personal data. So what we can do is we can leverage something like Presidio to take the production data, strip out all the PII entities, and then we get a PII-free version that we can use to train our models, to analyze our data, to build dashboards maybe, and not worry too much about all the privacy in the data. A second scenario is around monitoring production systems. So production systems that are already deployed, they output a lot of logs, and these logs often contain PII data themselves because users interact with these systems, and often different regulations don't allow us to touch this data. So we could have maybe some scheduled task to take these logs, clean the PII data, and then we could work with them. And a third scenario is about taking our data maybe from the on-premise environment to the cloud, or maybe collaborating with a third party around this data And in this case, we could use such tool to clean out a PII. Maybe we won't be able to clean everything, but a lot of people around the world are working on manual scrubbing and manual removal of PII data in these scenarios, and we could at least automate this process to some extent, which is also something that reduces a lot of manual labor. So these are the main scenarios. Obviously, there are some more. Next, I'm going to show some demo. This is a screenshot, but you could just go to the URL on top and try it on whatever you'd like. So on the left-hand side, you can see just unstructured data. It might seem like it has some structure, but the tool is not aware of the structure in this data, and the data contains all kinds of different PII entities. And on this side, on the right side, you can see how the data looks like on the other side. So we have identified things like credit card. It used to be a 16-digit number, and now it is replaced with a token. And same goes for all the other different entities in the original text. And in addition, we get the confidence that Presidio thinks about every prediction that it had made. So for the credit card version, for example, the score is 1 because of various factors that I'll describe in a minute. Going into one example a little more deeper. So let's say I'm writing something like my phone number is this and that. Don't try calling me. On the other side, you see what Presidio identified, and on the bottom side, you see that the score is 0.85. Now I'm going to change the sentence a little bit. Instead of phone number, it's going to say my pool card number. And you see that it's still identified as a phone number, but the confidence is lower, and that is because we leverage the context of every entity. So surrounding words, if the word phone, for example, exists, then it brings or it increases the likelihood of this actually being a phone number. And if it doesn't, then it might still think that way because of the structure of the number, but the confidence is actually lower. So how does data flow within the system? Let's take an example of a HTTP REST request. This is just one example of interacting with the service. So we send some text into Presidio. It goes into the PII analyzer phase, which orchestrates different PII recognizers. So every recognizer is in charge of detecting one PII entity, for example. So we call all the different recognizers. We have the built-in ones that you get off the shelf, but you could also create your own custom pattern, maybe using regular expression or something else, or your own custom model and train your own machine learning model and deploy it within the service to detect your own PII entities. And every recognizer uses all kinds of tools that we'll talk a little later about, like regular expressions, checksum, named entity recognition, and context, which is the surrounding words. So we run all these built-in and custom recognizers. We collect all the results. We transfer them to the anonymization phase, where we could have one entity being redacted and the other being hashed, for example. So we have a lot of flexibility there. And eventually we get a response that contains the original text without all the identified PII entities in it. So more technically, how do we identify PII entities in text? So how do we identify this private data? The more basic stuff, I guess, is using blacklists or regular expressions and checksum. Then we could maybe do something a little more complex using some rule-based logic. And eventually we could train models on private data and then have them serve us during runtime to detect these PII entities during runtime. So blacklist may be simple, but it could be very efficient in some cases. So essentially, I'm providing the tool with a list of words that once it sees, it automatically defines as PII. Think about titles, for example, Mr., Mrs., Doctor, Professor. There's a finite list, probably, of titles, and I don't have to build a full-blown machine learning model just to detect titles. And another thing I could think of is to have this tool connected to my database, for example, and query my employee list. And every time an employee name appears in some text, I could redact it because it's in some SQL database. This is an example of how to provide Presidio with a blacklist of words. In this case, it's just 5 different companies, but you could customize it and build your own blacklist if you're interested. Regular expressions, so not very sexy, but very efficient. We essentially built some regular expression pattern, and Presidio just sifts through the code and looks for candidates that agree to this pattern. Once it had identified these entities, I could also add validation code that is, for example, checksum. So entities like credit cards and the Israeli Israeli ID number, for example, they don't only follow some pattern, they also should have some logic of which numbers are in this pattern. So if we see that the 16 digits, for example, agree to being a valid credit card, it increases the likelihood of this being a credit card and not just arbitrary 16-digit number. So we could use this as well as the surrounding words. Rule-based is essentially a way of defining our own custom rules to detect PII entities, and we could use all kinds of tools to do this. So we talked about blacklists. We could also do whitelist. So all the words in the dictionary are a whitelist, and every word that is not in the dictionary may be suspect to be a PII data. We could also use part of speech tags and dependencies, regular expressions, and these are things we get for free. So we don't have to run our Spacey pipeline or some other pipeline to extract part of speech. We get this out of the system. We could also look at the previous and next tokens, and I will show an example of recognizers that we've built using this technique. Last but not least, we could obviously train named entity recognition models on private data, and then have it served during production. And we could either use off-the-shelf models because some of them already know how to handle things like person names, locations, organizations, or we could train our own. So 2 example recognizers, one for address detection and the other of how we try to improve person, organization, and location detection using deep learning. So address detection is a pretty hard problem. The example here is I moved from Market Street to 23 Olive Road last week. So the task is to identify where an address starts and where it ends in order to de-identify it on a later phase. And you might have heard of address parsing, which is a model that you put in a free-form address into, and then you get, for example, what is the street number, what is the zip code, and things like that. So identify different parts in an address. And this is not the same problem, because here we have a very large body of text that might contain or not contain an address, and just put everything into an address parser would not give any meaningful results. So what you could think about as solutions to this problem, so you could train a model like a named entity recognition model. Some things to consider is that entities here are relatively long. So if a person name is usually 1 to maybe 3 tokens long, an address could be 10 tokens long, and I'm not sure that the current models that people use for names, for example, would work in this case. And second is that we usually don't have very big labeled data sets of free text that contains human written addresses. So this is something that's pretty hard to find. What we try to do is something a little different, a more rule-based approach using token lookup. So essentially what we did is we took some geospatial data sets from OpenStreetMap. It essentially contains a lot of addresses of places, points of interest, locations, and things like that. We took all the tokens from there and put them into a TRIE. It's a data structure that essentially allows you to efficiently query the number of occurrences of every string on your previously seen data. So words like street, road, avenue, boulevard will appear a lot of times in this data set, but words like Omri will not appear in that data structure at all. And then we take our input data that we don't know if it actually contain or don't contain any addresses, and we see how many times every token appeared in this try. So we see that words like street and road, maybe street names like market and olive do appear in this try, but words like last and week don't appear. And we already have some feeling or some understanding of where an address might be existing in this sentence. We still need to understand where it starts and where it ends, and for that we could go back to the address parsing task and come up with different candidates for where it starts and where it ends, put the candidate substring into address parser and see if we get something meaningful. If we did get something meaningful, it means that we're probably on spot on the address, but if we don't, we could maybe try and play a little bit with the start and ends of the sentence to see if we get anything better. A future work you might think of is to look at these counts as features and add additional features that you might find in addresses, like regular expressions for zip codes or for states, and train a model to detect address parts in free text. So this is one example. And the other example is around doing more traditional named entity recognition. And I'll talk about how we created a data set, which models we used, and some interesting results. So data set creation, again, like the address problem, PII data sets are hard to come by. It's not like people give you their PII data. It's the last thing they would want to do. And you have to come up with creative ways of generating your data. So the solution we came up with is to augment publicly available labeled data sets. So you download a labeled data set from the web, for example, that has a sentence like, thank you, Tim, and Tim is labeled as a person. You replace this with a token or a template saying thank you person, and then you could generate new sentences using fake PII like thank you Rick, thank you a full name, Amanda Marks, or lowercase, thank you Yoda, for example. And then you could see how your model behaves on much more data than originally was in this labeled data set that you started with. So this is actually a little easier said than done. And we thought it would be easy, but it wasn't that easy. So some examples. There is a difference between location, which was the label that was given, and nationality. So if the original sentence was the North Koreans know what's in the agreement, and we replaced North Koreans with Germany, then we get something like the Germany know what's in the agreement, and that's not grammatically correct. And we had to fix this by adding a new nationality label, for example. Same goes with gender. So maybe the original sentence was talking about a female, and we injected a male name. And sometimes person names are inside institutions. So the Obama administration was replaced with maybe the Gaga administration, and then you have to think if you want this or don't want this in your data set. And some funny sentences. So a lot of these labeled data sets talk about take data from the news, and obviously Israel is all over the news in many places. So this was originally a sentence about Israel and Palestine, and once we replace everything, we get something like Dutch gunmen at the London refugee camp in the southern part of Budapest Strip opened fire on Australian forces. And again, you could think if you'd like this or don't like to have it in your data set. And we've also encountered a lot of wrong labels in these data sets. And these are the data sets that people use to note state-of-the-art results, for example. So one of the data sets has a lot of sentences from the Bible, but they're not labeled. So because they are holy or something, nobody labels Jesus or Judas or Paul, and then the model itself needs to have some divine understanding, I guess, in order to get these right. So actually our data set is a little more clean than the original data set that we started with. So we took 8,000 templates, and we generated 80,000 samples, and we did all kinds of approaches. We tried to train a deep learning network from scratch. We used pre-trained embeddings, or we tried to fine-tune, so continue training an already trained model. And the factors that we cared about is obviously the accuracy, the performance also, because Presidio is currently very fast, and we don't want to get lower performance than what we had before, and interpretability was also something that we had in mind. The metric we optimized on is F2 because recall is more important than precision. We don't want false negatives or false PII to slip through the process and reach the final data set. So we evaluated various spacey models and FLAIR models. So FLAIR, if you are not familiar with it, it's an NLP library that is built on top of PyTorch. It has all kinds of tweaks that actually bring state-of-the-art results on many tasks. Specifically, there is the FLAIR embeddings, which is their way of calculating embeddings. And another nice feature is that you could stack embeddings from different sources. So you could have BERT and Elmo together or things like that. We use BERT on one model, and we use a stacking of GLOV and FLAIR embeddings on the other. We also use conditional random fields as just a baseline approach, which is a little more interpretable, I guess, than the others. So regarding results, it's a little too much, so I'll go over it step by step. Let's start from the bottom. The black bar is the F2 score for was PII detected or not. So we're less interested in whether it got location as person or organization as location. We are more interested in whether we got the PII right or not. So this is the metric we cared about. And you see that CRF actually get pretty good results, around 80%. We tested various SPACY versions. When we started this experiment, SPACY had 2.1, 2.0, and it didn't recognize anything that was lowercase. And that's one of the reasons why we've decided to do this ourselves. While we were in the process, they released a new version, 2.2.0, that does identify things in lowercase, and it's actually a little better than what originally was in the previous version. You could see that if you take the SPACY off the shelf, or you fine-tune it, or you train it from scratch using fast text, you don't necessarily get better results. And that was kind of surprising, because we were sure that we would actually beat the off-the-shelf model, but we didn't. We did see that Flare, for example, does provide much better results, but it was also very, very, very slow. So if we look at the inference time or the training time, so Flare wasn't production ready at all. It was an order of magnitude slower than SPACY that we currently use in production. CRF was actually an order of magnitude faster than SPACY. So if you need the best model ever regarding accuracy and you don't care at all about performance, you should use Flare. But if you have very strict performance requirements, you should use CRF. The differences in accuracy are not very, very, very big. Another thing to consider is about training time. So it takes less than an hour to train a CRF. It takes around a day to train a SPACY model, but it takes maybe 5 days to 2 weeks to train one Flare model all the way. So that's another consideration, because it's a lot of data science time and a lot of GPU time. So future work for Presidio is to continue improving models, supporting new entities, continue supporting multiple languages, and maybe build models for new languages, support native Python usage. So right now, Presidio is something you could deploy, or you could build from source, but you can't pip install, for example. So we're working on having a pip install version of the identification part, at least, that you could at least experiment with, and this is coming soon, very soon. That's it. So feel free to try it out. Let us know what you think, and feel free to contact me or the others on the team if you have any questions. Thanks. Questions? Okay. Yeah.
How many languages do you support?
So we have regular expressions and models just for English now. But the infrastructure itself supports more languages. So if you added a new recognizer for French, then Presidio would know to go to, and you send something in French, it would know to go to this only the subset of recognizers that handle French. Okay. More questions? Yeah.
Are you working with GDPR and HIPAA to take some kind of formal approval for this tool?
So a lot of the customers we're working with do care about GDPR and HIPAA, but I'm not sure we could actually solve the problem and say you are GDPR compliant, because it depends a lot on the domain you're applying it to and the accuracy of the models in this domain. So this is something that definitely gives you a good advantage towards being GDPR compliant, but you'd have to make sure that you are fully compliant in addition to what you're doing with this tool. You mean other entities or other?
Kind of entities, other domains.
So yeah, so first with other domains, so the data sets we use come from different domains. As I said, you have news, you have the Bible, so it's a multi-type of domain, and we got pretty good results on all domains. Regarding new entities, you would have to come up with your own logic. If you have your own account number, for example, or you need something like I don't know, Ukrainian addresses that we don't currently support, you have to come up with your own logic. But you could do, if it's just a regex, for example, you could just send it through API. You don't have to redeploy this. And if it's a model or some custom logic, you'd have to add it to the code and redeploy it. More questions? Okay, thanks.